All right. Well, good morning, everyone. Thanks for showing up. 10 o'clock is not too ridiculously early, but it's not the latest either. So good that you made it here. Well, welcome to, officially this is called like Edgar's Guide to Python and Neuroanalysis. So in case you haven't quite figured that out, my name is Edgar. Edgar Walker. I'll be your instructor. And just a bit about myself, I'm a computational neuroscientist slash machine learning researcher. I mean, at least in terms of the topic I work on. I'm in the Andreas Tolia's lab. I finish up pretty shortly. If you make me start talking about my research, of course, it goes on and on, just like any researcher, so I'll spare you this time and talk a bit more about what's probably relevant. In case you were born enough to read my intro about my background, you already know it, but I actually been teaching for over 15 years. Yeah, that means I've been teaching ever since like 14 or so. I'm not going to go into details. So all to say, like, I've been doing this a lot. It's obviously my hobby, right? Also, I've been programming for quite over 20 years, actually. I think I started programming back in 7th or something like that. So it's been I mean, it's not like I've been programming in Python for 20 years, but at least I've been programming for some time. And so programming and just coming up with algorithms and stuff like that, it's kind of second nature to me by now. I see a lot of benefits. It's pretty fun. And part of the point of the whole course is to kind of get you started on that track. All right, so, I figured that we could start with this. By the time you're here, this suggests that, okay, you're pretty much convinced that Python is the way to go, or at least someone convinced you. You probably have to be here and learn Python. I must say, you kind of made the right choice. Python is a good language to learn. One, because it's pretty straightforward. It's one of the simpler languages to learn. But that's not to say it's not powerful enough. It's actually as powerful as pretty much any other languages. Now, if of course, you're really into this, you're going to start saying like about, well, of course, any language that's Turing complete is equivalent to each other. Okay, fine. The whole point is it's straightforward and it's very useful. Now, one big benefit of it is it's completely free and it's based on open source coding, which means that, okay, unlike MATLAB, for example, you don't have to pay license. If you go somewhere else, Python can come with you. You don't have to worry about paying a license, which could break your wallet. That's not part of a concern. Also have a huge active open source community behind like the Python itself and also a bunch of libraries you get to work with. Now the big benefit of Python is that it is actually actively getting used in the field of science. Physics, neuroscience, you kind of name it, there are some Python libraries and Python applications already getting used today heavily. And of course, it is also one of the places where you find cutting-edge libraries for topics, like very hot topics like machine learning nowadays. If you're ever at all interested in doing something like neural network or the cool things that's going on right now in machine learning, Python is the language of choice. You pretty much actually don't have a choice but Python in terms of being at the forefront of neural network research. So those are my statements of why you probably should learn Python. So with that out of the way, let's just get started. So go ahead, visit this link. I also posted this link on Slack so you can click instead of having to type it. And I'll do the same on myself. I already have an account open. Exit. I posted on the Python workshop. There's a link there. If I can find the Python workshop. There. Right there. If you click on it, it should take you to, yours wouldn't quite look like mine, but it should take to something like login. And if you log in, then it will actually kind of go through this like permission screen based on GitHub. So hopefully after you go through and click on necessary green buttons, it eventually takes you to something that look more or less like this. Probably have everything closed out. So it'll look closer to like everything shut down. Let me just imitate that. So it will look probably more like this. Okay, everyone good? So what you're seeing right now, this is an environment called Jupyter Lab. So the fact is, like, this is all hosted under this special service called Jupyter Hub. This is the service I put together. Wasn't like I set it up such that you can log in and get to this. But once you actually log in and the interface you get, this is called Jupyter Lab. It's one of those like interactive browser-based application that comes with Python, or you can easily install with Python, that you can use to actually type code in, execute stuff, and also take notes alongside with it. So it's actually a pretty good tool to use. In fact, I actually make use of it on a day-to-day basis for my Python programming. So it's a good one to get used to. So just to get a bit used to navigating around, the first thing you probably want to do is click on the 00 getting started to Jupyter or getting used to Jupyter notebook or something like that. So if you double click on it, oh yeah, that's right. Yeah, my bad. So your top folder should be work and public. So double click on work, get into work folder, and then click on the 00 getting started or getting used to. All right, everyone in? Open it up fine? Okay, good. I was a bit worried like whether the server's going to be able to handle like number of people, but so far it looks good. So, I mean, you could read through it. This is typically how I'll be distributing my course material. It's basically in the forms of Jupyter notebooks. So these are like files I put together with a bunch of text as well as a bunch of code to go along with it. It's also a perfect environment for you to add your own text in your code. So this is going to be the primary means by which we'll be working through the workshop or this course. So you don't have to read it. This is more like I wrote the whole thing in case one, you're going to blank out and not listen to me and you have to catch up later. Here's pretty much everything you have to know in there, to the point that it's almost complete. You don't have to come to the course and look through it. At least now you know where to find this information. Preferably, of course, you pay attention and try to be interactive about it so you can learn more from the experience. So basically, the basic things are, in Jupyter Notebooks, there are these cells. So if you click on it, you notice that it has different like divisions. These are called cells. And if you scroll down a bit, you find a cell that looks a bit different from the rest. So obviously these are just texts. And here's what looks more or less like a code, right? So these are code cells. So if you click on it, and if you actually type Shift Enter, it runs the cell. It actually executes the code in the cell. And in this case, you notice that you don't worry about understanding the code quite yet. I mean, if you already know it, then I'm kind of wondering why you're in the course. Like you're supposed to be learning this over the next few weeks, right? But obviously, if you based on the message, what it's doing is it kind of grabs today's date, prints out a message saying like, okay, this is today's date. This is the first day of the Python Scientific Workshop, and prints some information out. And you can repeatedly run the same cell, so just click again and then Shift Enter. And because this is taking the timestamp, every time you run it, it grabs the current timestamp just to show that this is actually running right now. It's not something I ran and just pasted a text. This is actually running in front of you, or running in a computer that actually lives somewhere online. Okay. So for the first two sessions, today and next time on Thursday, this will be the environment we'll be working with. So basically, I prepared this work environment, Jupyter Hub, that's hosted somewhere online. If you're ever curious, I'll be happy to talk about it. But it's basically a computer I provided perfectly, complete with all the necessary libraries and everything it takes for you to just start diving into Python, so you don't have to worry much about the setups. Now that being said, if I complete the whole course just with this and say, okay, now you've learned Python, and the only way you'll know how to run this is on my computer, that's a bit useless, right? You kind of want to get out of this course knowing how to run it on your computer or the next computer in the lab, be able to actually use this for your own good, for your own research. That's the whole point. So the course wouldn't be complete if I don't tell you how to set these things up on your own machine. So that being said, the way I'm going to approach this, and hopefully you've already seen it, is that I've already provided you with installation instructions for Python. If you haven't quite done it, it's fine. I specifically said it has to just be done by week 2. I just want you to try on your own, follow the instructions, trying to set up a Python, namely using this packaging thing called Anaconda distribution to set up Python on your laptop. If between today and then next session, the first session on week 2, so that'll be Tuesday next week, if you have any issues, you're supposed to approach me, or try a bit first, and then if you still have an issue, come approach me so I can help you debug and help you get it set up. So ideally by next Tuesday, you actually have a working Python setup on your very laptop, and we'll actually start using that setup instead of this setup. Okay? But for the first 2 sessions, I just wanted to dive in so you don't have to worry about all these configurations. Then we can focus just on learning Python. But from next week, we'll actually be using Python on your very laptop. Sounds good? So make sure you try it. Please don't come on Tuesday, 8 a.m. saying, I just started trying, it doesn't work. I mean, I'll probably help you, but it'd be much nicer to me if you just try it ahead of time, okay? All right, so now you know how to execute a cell. You can scroll down. Another thing is you can learn is like if you click on a cell and if you do Shift Enter, it executes and goes to the next one. So what this means is that if you just keep on hitting Shift Enter, Shift Enter, Shift Enter, or just hold Shift and keep on Enter, 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 it actually runs through a sequence of your code snippets. This is pretty convenient because eventually you might have a bunch of code written in multiple cells and you just want to run from top to bottom. All you have to do is just shift enter, enter, enter. Okay. So now you've seen it. I expect you to be able to run code cells. Now it's not as interesting if all you get to do is run my code, right? You actually want to write your code. You're here to learn how to use Python. So meaning that you have to learn how to edit stuff. So first thing first, let's actually learn how to edit a cell. So if you actually take any cell and actually double click on it, it goes into edit mode. So here I prepare exercise. You don't have to do it. Maybe this is something you can try on your spare time outside of the course. Here, this one has intentionally a lot of mistakes. Even actually, I've used it such that if you change the word character orders but preserve the first and last characters, you can actually read it. So it's intentionally more difficult for you to spot this fact it's spelled wrong. But anyway, so you can actually just try editing it. There's nothing different from typical editing you see in any other editor you're familiar with. I'm just going to type the right version. Okay. And once you're happy with edited text, you notice that if you just leave it like that, it looks different from the rest. You actually want to make it look stylized and looking nice. Well, you just run it. So if you run a text cell, it stylizes it. Make sense? So you can actually go to any of these, you can open up and make edits, and if you just run it, it puts it back to where it's nicely formatted. Alright, so that's one thing. So being able to edit is a start, but yet, of course, that's not enough. You actually now want to create your own cell. Right? There are a couple of different ways of approaching this. One way is as documented here. Say if I click here, and now if I go over there to click on the plus sign, it creates a new cell. By default, it's going to be a code cell. So this is one way to do it. Another way is that if you're outside of edit mode, so you can actually get out of an edit mode by hitting escape. So now nothing seems to be in editing mode, like you're not having the blinking cursor, you're outside of edit mode. If you're outside of edit mode, you can actually create a new cell below where you are just by hitting B, like a character B. And you can create a cell above by hitting character A for above. It's a pretty convenient trick. So this way, if you're just moving around, you can quickly create a new cell. And if you actually want to keep on navigating here, as long as you're not in edit mode, you can just hit up arrows and down arrows to move through your cells. And if you want to edit any of them, you can either double click it or just simply hit enter and it gets into the edit mode. Okay, so these are some neat tricks to be quicker at Jupyter Notebook. Yes? Yeah, okay, so I'm coming to that. Yeah. Good. In fact, there's like a deleted unwanted cell coming up.
I'm sorry, could you repeat the in and out of edit mode?
Sure. So if you're in currently edit mode, which you can tell by blinking cursor, you just have to hit escape character on your computer. There's the top left thing. And you can get back into the edit mode by double clicking or hitting enter. Okay, so this toggling between edit mode and this outside of edit mode called command mode might not be the familiar thing. If any of you happen to be a Vim user, which I doubt, this is like a very familiar concept. If that's not the case, then this is just something to get a bit used to, but hopefully you find it pretty convenient. The command mode lets you get access to a lot of shortcuts with just single keystroke. Alright, so now you've created a bunch of cells, you probably don't want them anymore. One way to delete is just highlight the cell, so just make sure it's selected. You don't have to be in edit mode, but have it selected. And if you go into, actually is it not showing the thing? Then there is delete cells. If you go to notebook, then there's delete cells. So this is one way to delete it. Of course, this is a bit cumbersome. Another way is that as long as you're outside of the edit mode, so you're in the command mode, and if you're highlighting the cell, you hit the D character twice, and that deletes the cell. So go ahead and delete the unwanted cells you created already, just to get a practice. You can create new ones and delete it. Just get used to that procedure. Yes? So you're already asking for advanced stuff. Fair enough. So you could do so. So one way to do it is in the command mode. Start with the cell. So it's going to be just basically batch selection. You hit shift, right? And once you hold shift, if you move down, it selects multiple cells. And now if you hit delete D twice, it deletes all of them. All right, so last but not least, was it last but not least? Yeah, last but not least. Last but not least is the cell type. So if you actually, let me go ahead and create a new cell here. You notice this is like, it looks like a code cell in the sense like if I type anything here, this is actually going to be interpreted as code. If you actually want to write your text because you're trying to take notes, you have to convert this into a markdown cell. So there are a couple ways to do that. You can highlight the cell you want. You notice that there's a drop down here. It's currently saying code to indicate this is a code cell. You can just select markdown. It puts it as a markdown cell. This means this is now interpreted more as like text or something that's a notes. You can also toggle back to code just by the drop down again, and now this is a code. And of course there is a command mode shortcut. So if you're, as long as you're outside of the edit and if you're on the cell, if you hit if you hit M, it toggles into markdown. If you hit Y, it puts it back into the code. Okay? Make sense? There are a bunch of other commands I'm not covering because the whole point is not to try to make you the world expert on Jupyter Hub or Jupyter Lab, just to get you started so you can actually follow the rest of the exercises. But there are many more commands that you can learn, and if you're ever curious, if you go to the commands, there's a whole listing of all sorts of things you can do in Jupyter Notebook along with the command mode shortcuts associated. Okay? Any questions so far? Make sense? All right, so this was just getting you started with the Jupyter Notebooks. Now let's actually get started with the actual Python. So this time, double click on 01 getting started with Python. And this is probably going to take a long time to load, so it might look like it's stalling. Just give it some time because this is a pretty long notebook. And this is all of us trying to access at the same time, so we just have to give server a bit of break and let it load the whole thing. But eventually you should get there. All right, everyone there? Still loading? There? Okay. All right, so this is where we actually get started with the Python. Like, anyone still having trouble getting there? Okay, we're waiting. All right, we'll just wait a bit more. Good? Still loading? Still loading. It's also a bit dependent on your computer. So there might be a computer-to-computer fluctuations in time. Okay, we'll just start stepping through. If it never loads for you, then I'll try to come and troubleshoot for you. Okay, so there are multiple ways of approaching how to get started with Python, right? I could be very much of a CS 101 approach where I try to teach you principles of what a programming language is, what a computer is, how it works with the memory. That's all fun and good, but what I want to teach you is how to be very practical. Like, learn Python as a tool that actually you can already start using for your own good sake, right? Doing your research, just solving problems with it. So one way to think about Python that's probably as practical as possible is just think of it as a calculator. If anything, you can already start using Python as a bit fancy calculator, right? So here I'm basically just saying, well, if I just want to say, I want to convert from inches to centimeters, like 12 inches, I wonder how many centimeters that is because I quite don't understand inches still, right? Well, I know the conversion factor is 2.54, so 12 times 2.54 is, okay, that's 30 centimeters, right? Or if I'm now trying to convert from Celsius to Fahrenheit because I only have a sense of Celsius and someone wants to know Fahrenheit, I always have to do this conversion in my head anyway. So, if you already committed this to your memory, you multiply by 9, divide by 5, and add 32 to it, right? Everyone knows this, huh? Okay, so that's 99.5 Fahrenheit. Of course, Python respects all sorts of arithmetics you learn in, back in middle school, high school, right? Like all the algebraic precedences. Like multiplication will occur before additions, parentheses are respected, all these arithmetic precedences are respected. So here you can do a bit more complex calculation or complex calculations. I was going to make you guess what this is, but I don't think I care enough, so I'm just going to run it. It comes out 10. Now, one thing that might catch you with a bit of surprise is if you want to do exponentiation, you might be used to doing the caret notation. In case you didn't know, that symbol is actually called caret. So instead of 5 caret 2 to do 5 square, in Python you do 5 times 2. So this is just one catch you just have to get used to. So here, 5 squared is obviously 25. Okay, so throughout this whole notebook, I'll have a bunch of these exercises. These exercises are actually meant for me to be doing a live coding with you, but it's also meant for you to try it at the same time, okay? So if you just hear staring me coding, you're not coding, you're not learning to code. So try to actually work on the problem with me, okay? I might not cover every one of the exercises. In those cases, I'm just leaving the exercise for you to complete. And towards the end, I'm actually going to give out a homework assignment, and I'll talk a bit more about it when I get there. Okay, so first one is just very straightforward. How many kilograms are in 12 pounds? I even give you a hint, like, oh, there's 0.45 kilograms in 12 pounds. So anyway, how do I do this? Volunteer. What's the math I do? It's not a trick. 12 times, yeah, times, right? So how many pounds? And then 1 pound is 0.45 kilograms, so that's 5.4 kilograms. Okay, this is a bit more interesting, and this is now getting more like what you might actually want to do in the real life, right? You want to take average of multiple numbers. So we'll get to more fancy and cooler way of dealing with this later in the course, but for now, all I can do is just take the sum, right? And since there are 3 numbers, I divide it by 3, and I get an average. Now notice it doesn't quite tell you 8.7. Later there's like 8.7000000. I'm not counting probably auto, right? But 0001. There's this a bit of trailing incorrectness. This has to do with the fact that they're trying to represent these floating point numbers or decimal numbers in computer memory. And when it comes to representing some of these numbers, there's a bit of inaccuracies involved. Computers cannot necessarily represent every floating point number perfectly correctly. So it's something to keep in mind. Usually doesn't matter, but when you actually start dealing with computation that involves very small numbers, these kind of precision errors actually start to affect your computation. All right, so here, I'm also kind of just showing off the fact, yes?
So what do you do? What can you do about that?
So when you actually have problems like that, what you try to do is you try not to work with small numbers. So it might sound stupid, but that is actually a real solution. So for example, if your thing involves working with something that all lives in the order of 1e to the negative 15, well, if you know everything is 1e to the negative 15, you factor the 1e negative 15 out, just work with the bigger number sets, do your computations, and at the end either multiply 1e negative 15 or just don't do anything about it because you know everything is scaled by it. So these kind of small tricks of not trying to be in this super small regime or on the other hand, super large regime actually helps a lot in getting your computations correct. And this will be something we'll try to cover mostly in week 3 when we start solving actual neuroscience like computations. Okay? Okay, here I'm just kind of showcasing 2 things. One is the fact, hey, I can type mathematical equations pretty neatly. If you're curious how this is done, if you just double click it, it's actually typing in this notation called LaTeX. If you're ever going to be typing a lot of equations, then maybe you've been used to like something like Microsoft Equation or something like that. I highly recommend learning LaTeX because it actually gives you a lot of capabilities. Here I'm actually successfully like stole the notebooks because it's actually, lately this has been having a bit of an issue with this notebook. So I'm going to skip it for now. Basically what I'm trying to show you is like how to compute the variance, right? So I gave you an equation. It's not showing nicely. Hopefully it's still showing nicely as an equation on your laptop, right? So if I'm trying to compute a variance across 3 numbers, the first thing I want is the mean. Well, these are exactly the same numbers I already computed the mean for here, so I'm just going to use that number. So it's 8.7. So what I can just do is 7.4 minus 8.7, oops, 8.7, square it. Remember it's multiply 2, all right, plus 11.9 minus 8.7. Actually, it's good to do this way. 8.7 square, and then finally 6.8 minus 8.7. If you feel like this is one of the most cumbersome way of computing variance, I completely agree with you, and this is not going to be how we're going to proceed with the course. Like very soon, I will tell you how to do this a bit better, actually quite a bit better. Okay, so far so good. You can use it as a fairly sophisticated scientific calculator, right? But that's not the only thing Python can do. It can do far better than this. So as you start to work on more and more complex calculations, sometimes you want to reuse values that you already computed. In fact, we've already seen a case of it. When we actually compute the variances, we actually needed the mean. So rather than me having to type 8.73 times, it would have been nice if I could store it somewhere and just kept on referring to it. Especially if I want to recompute this. If 8.7 happens to be a bit off, or maybe I change the numbers and have to recompute it, if I had just one way to refer to that mean, rather than having to retype it 3 times, or if I had 7 numbers, I had to retype it 7 times, it would save me a lot of time by putting it somewhere. Now obviously, I mean, you're kind of already seeing the name of it, so obviously that's what variables are for. So one way to think about variable is just somewhere in the memory that's named. It's a name storage or name location in your memory where you can store values in. We'll get a bit more into details shortly on how exactly memory variables work in Python, but for a very moment now, you can think of it as just a box living in a memory where you can put your values in and refer to it by name, right? So if I actually do this, so in Python, when you want to create a new variable, all you have to do is just come up with the name and assign it. And that creates a variable. Now it didn't seem like it did anything, but you can actually check the fact it created a new variable by referring to the name by itself. And this causes it to print out the content of the variable. In this case, since we assigned 100, it is 100. So far, so good? Now, of course, I can start to use this in my computation. So here's a quadratic equation. I want to compute it for x equals 100. So if I execute it, it computes it. So now we actually have variables. Let's actually approach the mean and variance problem so it's a bit nicer, right? So this time instead of, I'd say I'm actually want to take the mean and variances for these 3 numbers, 10, minus 8, and 9. So instead of like doing it all numerically and like putting in one big equation, I first assign these 3 numbers to A, B, and C. And then I just use that to compute my mean first. Okay, so in this case it's 3.6666. Again, notice that it's at the very end it's 5. If you actually do this, this is supposed to be 3.6 with 6 continuing forever, right? This is a case in which it's not completely divisible. But in terms of fitting in the memory, they cannot represent this 6 going infinite, so it would truncate it somewhere. So this is, again, the case of imprecision or a bit of an error that will be introduced because of the precision issue in the computer. Okay? Now, of course, I'd rather actually keep the result of my mean into another variable, so let's just do that. So now mean hosts that computation. Yeah?
So when you put a value for each variable, then how long, like, do you have to reset that if you want to change it? How long will that be a value forever?
So until you reset it. So here it will persist actually throughout the whole session of your notebook. Yeah. So unless you explicitly delete it yourself, it wouldn't disappear, unless you restart the whole notebook. If you just refresh the page, by the way, this whole thing persists. That's the one nice thing about JupyterLab is that if you just happen to say go back in the browser or hit refresh, it actually doesn't kill any of the computation or any of the memory that you actually created. All the variables will survive. Yes?
So if you start another notebook, then the variables will be treated as separate, although they have the same name, they will still be different values.
If you start a new instance of a notebook, that is correct.
Does it give you errors? Does it give you errors? I mean, if, for example, here I'm trying to use the mean, but it didn't define me.
Yes. In fact, I think I had a section where, no, I actually did not have a section. So yeah, in fact, yes, if you actually try to use something that's not defined, so let's actually try it, right? Like say I haven't defined y, so if I just look at y, it gives you an error, right? So, so one quick thing about errors. It's a pretty good leadway into it. You will encounter this a lot, okay? And you will continue to encounter this as long as you program. One notion or one myth I want to get rid of from very get-go is this notion that somehow as you become a better programmer, you're not going to run into errors. That's completely not true. Debugging, basically getting rid of error, is going to be the norm as long as you program. Right? After 20 years of programming, I have errors every single day. I have bugs in my code, and it's an accepted portion of the programming. Okay? So don't think of errors as some indication you're not being a good programmer. That's completely not the case. It's just you attempting something, and if it just doesn't quite match up, they're just telling you back. So learn to interpret it. Don't be afraid of it. Just learn to know where the error is coming from. Learn to be able to get rid of them. And the more you do, the better you get at it. But all I'm just saying is like, just because you've been programming for 20 years doesn't mean you're going to write a perfect code every time. At least hasn't happened to me, hasn't happened to any good programmer I know of and respect. Okay? All right, so I'm just going to leave the error as is. Now I'm actually using the variables I defined to compute variance. So I'm going to, same exact equation, but notice I'm replacing everything with the variables. Yes?
So if you change the value of the variable after you've already established them previously,
Yeah.
it doesn't change anything before, it just changes it from there on after.
It only changes from there on after, exactly. So in this case, let's actually see that. So here if I do var and compute this, and I'm just going to type it by itself to see the content, so it's 68.2222. Right? Now if I go back to the cell where I define A, B, and C, right? And say let me just change one of the numbers to something that's fairly big, like 1,000, right? I rerun this cell. Now the mean changed. I'll rerun the mean assignment, so the mean is updated. And now if I go and rerun this guy and look at the content, now it used the new values of A, B, and C to compute the variance. Okay? But this also means that if you compute variance and later on change A, B, and C, but don't recompute variance, variance is going to stay what it was defined earlier, right? So you could run into the case of inconsistency, right? Don't expect just because you use A, B, and C to compute variance that it will always be the correct variance for any A, B, and C you ever put in. This is more of, for this time, it computes it, assigns it, and that's all it is. As far as variance is concerned, it has nothing to do with A, B, and C, aside from the fact that it was just used once to compute the value. Okay?
So would it be better to put linked variables like that within one cell?
Yes, that is correct. So it would be better, at least keep it close, right? So in order to avoid errors, and this goes both for notebook settings like this, where you can go up and down and execute any cells in the order you prefer, it's actually a good idea to keep related variables close to each other so that it's obvious that it's related, right? If you change it one place, it becomes obvious that it actually affects these results, or you have to recompute those results. One of the worst way to program is have completely scattered variables. It's like that's one way to create a bug in your code. Okay, so here I'm just saying like compute variables, store two numbers. You can quickly try that. I'll compute the sum and product of two numbers and store into the variables as well. So I'm just doing something like, right? Nothing special. Here I'm just reusing the name. It could really be anything. It could be A, it could be. I'm just doing that, and I'm gonna add the sum into variable called total. So one key point, and I was gonna get to, but I might as well say now, is to try to name your variables meaningfully. Here, since we're just doing variables for the sake of demonstration, I don't really have meanings associated with the variables. In your real code, your variables tend to stand for something concrete. So if it stands for temperature, call it something like temp, temperature, something that's obvious what it stands for. Don't call it X, don't call it Z, don't call it like F, just because, right? Those are ways by which you confuse people who read the code, but also yourself, right? So try to be as descriptive as possible. That's the rule for good variable naming. And here I'm just going to say product is equal to this. And just to see, I'm going to look at it. Looks correct. Okay? So far, so good? All right. Now, one nice trick, this is actually fairly Python specific in that you may not necessarily find this in many other languages, is ability to do multiple assignments simultaneously. So can you guess what happens if I say x, y, z equals 1, 2, 10? What will be the value of x? Can you guess? Exactly. So yeah, that's exactly how it's going to work. So this ability to do multiple assignments is a cute trick. It might in itself not be the most useful features because you could just say x equals 1 and then y equals 2 and z equals 10. But one place this is actually pretty nice is when you want to swap two variables. Right? If you don't have this feature of multiple simultaneous assignments, if you want to swap variables, it actually requires yet another variable to temporarily store your value. So you can kind of think about how swapping would work, right? If you imagine just swapping content of two boxes, you have to actually take the content from one box out and put it somewhere else, and then take the content from the second box, put it in the first box, and then take the content that came out of the first box back into the second box, right? That's how you swap. So this temporary location has to be something. So if you typically want to swap variables, it requires another variable, and people usually call it temp or something like that. So in many other languages, swapping requires yet another variable. In Python, though, because of this simultaneous assignment, swapping is pretty straightforward. All you have to say is that, let's say here, x comma y equals y comma x, and you see that it happily swaps the two variables. That's one neat trick. All right, so yeah, we're going to talk about good variable names. I already gave you my spiel. There's correct variable names versus incorrect variable names. These are called identifier rules. Anything you name in Python, like variable names and later function names, have to follow certain rules. Most of the time, your intuition will be correct. Basically, it shouldn't start with a number. It has to start with alphanumeric character. It can contain numbers, right? So it could be like ABC 1, 2, 3. That's totally fine. It just cannot be 1, 2, 3 ABC. Right? It can contain underscores, and it is somewhat recommended to use underscores. It cannot contain spaces because the moment you put space, Python thinks you're done defining the variable name and move on to the next thing. So if you have multiple words that you want to use as part of variable, you typically just put it connected with the underscores. So for example, I want to say something like mean score. This is how I write my variable. Right? Please don't do something like this. This is really hard to read, right? Another convention you might be somewhat familiar, maybe from other language, should be something called like this, which is called, well, this is a form of camel casing. This is called camel casing because every word you have is like a hunchback. This is actually not the recommended practice in Python. If you really ask me why it's not recommended, well, it's just like, well, they decided that in Python, they prefer you use underscore, which is actually called snake casing, because it sort of looks like a snake. Right? So just try to follow the convention because this is how you're going to find other people writing the Python code, and more you kind of conform to it, the more it looks like legitimate Python code, and also just fits with people's expectation when they read your code. Okay? All right, so what are we saying? So one thing about this so far is like we've just been writing variables and doing computations. But once in a while, as you compute and do more and more complex computation, you want to print out messages. Maybe not necessarily to people in the world, but just to yourself. Sometimes maybe you're doing complex computation, you just want to see what is the result so far. Maybe you're doing some sort of optimization and want to see what is the minimum value it has reached so far. You just want to print out the message to yourself. So the way you print is using this function called print. And you put the message or the string of characters in double quotes or single quotes. So if you do run this, as you can imagine, it prints the message. In this case, good morning. Now print can be used not to just print out these strings, this sequence of characters, but it can also be used to print out numbers. You can also do expressions, so basically computations inside the parentheses. This is not so much specific to print, this is just the way Python works. If you actually see something to be computed, it computes it first and then uses the result. So in this case, if you say print 100 plus 10 plus 11, it does the summation first and then prints the result, getting 111. And you can actually combine multiple of these together just by comma separating them. And if you do that, it prints them out with spaces in between. So this could be a nice way for you to, say, annotate your variable. Maybe your variable stands for something and you just want to have a nice message, not just the content of the variable, right? So for example, if you have x equals 100, if you just say print x, it will just show 100. And from your perspective, it might be hard to tell what is 100. Well, all you have to do is say, put a string by it to indicate this is x that's equal to 100, making it a bit easier for yourself to interpret what's going on. Okay, so next one I do want you to do it, and this is more or less for historical reasons. Any programming course you take, any programming language you take, they have this notion of making you print out message hello world. Yeah, and if you learn any programming language, I'm pretty sure you are forced to print hello world, right? And as any good instructor, I feel a bit obliged to follow this. It's a bit of a curse, more or less. So please just go ahead, so let's get it out of the way. So print hello world, and once you verify it's printed, we'll move on. Okay, so at least you can say I've done hello world in Python. Right? Because otherwise I felt like someone's going to say, oh, you learned Python, did you do hello world? And it's like, no, and it's like, what kind of instructor is that? Right? All right, good? Everyone printed hello world? All right. Okay, so now what I want to show is a bit more practical example. So I'm doing this, mean and variance computation again. I'm just kind of, like doing a dead horse kind of thing, kicking a dead horse. Wait. Yeah. Anyway, so here the idea is that I'm going to do the computation again, but this time I'm actually going to print the results, intermediate results, as I go through the computation. So if I'm going to compute mean and variances, well, to me it made sense that at least I'm going to indicate, hey, I'm computing mean right now, I'm computing variances, and at the very end print out the whole results. So just look through it. This should be pretty straightforward. I just assign 3 variables. I first said I'm going to compute the mean. I compute the mean. No message shown about the mean yet. I'm just saying I'm going to compute the mean. I'm computing the variance next. Oh, actually, there's an error in my code. See, I make mistakes all the time. Compute the variances, and at the very end, you print out the results. So after you correct this error, and then you run it, you see it prints all the messages. So again, you can probably imagine as your computation gets longer and longer, your script gets more complex, it's really helpful for you to insert these print messages so you know what's going on. This is especially helpful if you're going to actually do something that takes a long time, right? If your script's going to take, say, 2 hours to complete, and if you show no message whatsoever, you cannot really tell whether it's actually doing something or whether there's a bug and it just stalled, right? Whereas if you know that periodically it tells you in print messages, by the fact it hasn't printed message for the last 1 hour, probably something's wrong with your code. You know when to stop. So printing message actually becomes pretty useful and very helpful. Also, it becomes very useful for debugging as we encounter. Okay, so now we actually getting more and more familiar with the strings. I actually wanted to introduce yet another trick. So notice that so far all we've done is put the string by the variable to be able to say mean equals the content of the mean. But sometimes you want a nicer string. Maybe you want to actually embed it in the middle of a message, right? Saying mean was equal to this, blah, 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 variance was equal to this in one string, one message in somewhat nicer fashion. Well, that's what format is for. So if you actually take a string and if you put this open close curly bracket, and then if you follow the string with dot format, so this is called a format method on the string, well, can you guess what's going to happen? What is the message going to be? The value of x equals 1, 2, 3, 4, 5, 6, 7, 8. Well, right? So this is called string interpolation. It takes the variable and puts it in the place of where we have the curly brackets. You have to use this dot format method to be able to do this interpolation. But it becomes a pretty nice way to be able to show a nicely formatted message. So for example, here, if I have 2 variables, I add it. Now I have a total. And I want to print this in one nice message with the variables in good place right after messages. Well, I can say a equals bracket, b equals bracket, a plus b equals bracket. And if I pass in 3 things, it puts it in that order. So no, the message looks something like this. So this becomes a neat trick to be able to print out a message in the way you exactly want it to appear. Okay, another thing, and this is slightly advanced but useful as well, is that sometimes if you have a number, like say especially a decimal number that has a lot of trailing decimal numbers, you may not want to show everything. You might actually want to cut it to certain precision. But if you just print it with the open bracket, it will show the whole thing. So one way to do is by doing some sort of control syntax that comes with the format. So one of it looks something like this, where in the bracket you say colon followed by, this might look a bit like cryptic, but 0.2f means it's going to be a decimal, and I want to show up to 2 decimal points. So if I print this for the 123.4567889, it will truncate at the 2 decimal points, giving me 123.46. Notice it rounds it up, right? Now, of course, if I make it into 3, it puts it out to 3 decimal places. Okay, so if you want to control the length of the number that gets shown, this is pretty nice. If you actually look into Python formatting, there are far more control syntax. You don't have to learn them at once. There's actually really no point learning them all at once. But once in a while, if you feel like maybe can I control this? How do I make this look nicer? It might be good to just pay a visit and try to learn a bit one at a time. This is actually going to be generally the case for any libraries you're going to encounter from now on. Don't ever try to learn library at once. Completely meaningless. Okay, like it's much better for you to learn a library, learn a syntax as you go incrementally as you use them. If you try to read the whole documentation, first of all, you're probably not going to retain the whole thing. Second of all, you're probably going to hate that library by the time you're done reading the documentation. And third, you just really haven't gained much. So it's far better for you to try to learn as is. Of course, I'm not saying you don't ever read the documentation. Sometimes reading the documentation or skimming through doc can give you, oh, this feature exists, I didn't know, right? Stuff like that occurs all the time. But it actually turns out that probably the better way to find new features is actually just read someone else's code. Someone else probably happens to know something you don't know, and you probably happen to know something that they don't know. So by reading each other's code, you say, like, oh, God, I don't understand the syntax. What is this doing? What is this method? What is this function? You look it up, you learn it, you start using it. So that's far healthier approach. Okay, so just one thing I also want to cover is the fact that actually strings are like values, like numbers. You can actually do some sort of operations on it. So I want you to guess first. So actually good practice with coding is try to guess what's going to happen next before you dive in and just try it. So if I add hello to world, what do you think is going to happen? It's going to give you one string, right? Probably. Yeah. How about this? What if I multiply a string? What would happen? It repeats it 5 times. What if I subtract 2 strings? Well, it turns out that's actually not okay. Yeah, you cannot do that. You cannot do that because it's really hard to define it well. Here you might have guessed, well, isn't that H? Yeah, for this case, maybe. But what if I told you, like, subtract, like, ELO? What is that going to do? HL? Right? It's not well defined. Hence, subtraction of string it's not well defined. It's not defined. It's not a valid syntax. Okay, so just, cruising around with the strings. One more thing to know is that, well, string is a value. Integer, the numbers, floats, those are values as well. It's a value you can assign to variable. So here I'm just saying I'm going to put my message hello world. I'm just keep on using hello world. Right? Into message, and now I have a message variable that contains hello world. I can look at the variable. Indeed, it contains that string. Now, if I print this, right? This is the second time you printed hello world, or at least the second time. Okay, this also means that you can put your values like strings into variables and do arithmetic on it, format it, and then finally print out what you actually want to print out. So you can actually do a bit of more logic on constructing the message you want to show. So here, for example, I'm going to put my first name and the first name on a variable called first_name. Notice the underscore usage here. Last name is Walker. I add them. Notice that I want space between them, so I put the space literal here. Yeah, that puts my name with a nice space between my first name and last name, not cramped up together. And finally, I actually take another message string, hello, my name is, open bracket, and I do the formatting. So this is the string interpolation we actually looked at, right? It injects your full name, the content of your full name variable into the brackets and creates finally this variable called greeting. So far, nothing is printed. Notice that I'm not printing anything. I'm just creating a variable that contains the string I want. Now I can finally print it, and it looks, pretty good. At least I'm satisfied with it. Okay, I think I will skip this one, but I do want you to try it at home. By the way, the thing is, like, this whole website thing is going to stay up for at least the whole week this week. So you can access it from Baylor, from outside, wherever. Probably don't try to access from your phone. It's probably going to, heat up your phone too much, and nothing's going to probably work well. But it works fine in laptops. I verify it works fine on iPad or tablets if you must. So try it, also just go through these things so it becomes really part of you. Okay, so far we already actually talked about a couple things. And one thing I want to visit is this concept of data types. So in Python, there are different values, and each of them have what's known to be the data type of that value. So you can actually find out what is the data type of anything by passing the value into this function called type. So it basically says, well, 10, the type of 10 is int for integer. Type of this 1.053 is float for floating point, which is the same thing as saying decimal number. And type of this string is, well, string or str. For each of these types, and we already encounter it naturally, there are literals, a way to write the values as is, and they already have that particular types. So 118 would be integer, 5.79 is a float. the way you tell apart integers from float is the presence of the period, right? In fact, if you actually put 6 point, that's actually a float. And you can verify that by just saying type of 6 point is indeed float. Okay, string literal could be in single quote or double quote, or single quote. And we also tend to refer to variables type, which is nothing but the type of the value that the variable contains. So if I assign 10 into x, and if I ask what's the type of x, it's really going to tell you the type of the value inside the variable, which in this case would be int. Now, one thing about Python, and if you happen to be familiar with the other more strongly typed languages like C, C++, and Java, is that in Python, variable itself doesn't have a dedication towards type, meaning that if you assign 10, which makes it an integer, you can totally assign string later. Just because you use it to store a number doesn't mean you have to keep on using it to store a number. You can actually assign whatever else you want later on in the course. So there's no fixed type associated with the variable. All right, so the next thing is the conversion of the data type. So sometimes you actually want to use strings and integers mixed together. So one question is, okay, if I take a equals 10 and b equals quote 20, which makes it a string data type, what happens if I add them together? Any guess? Error. Good guess. Or maybe you tried it, but good guess. Good. Yes, it's an error because it's not well defined. It doesn't really make much sense. If you happen to be familiar with some other languages, some language actually allows you to do this. I'm not going to really get into it because it's a problematic language. It's a problematic behavior. This is well defined. It doesn't really make sense you trying to add strings to numbers. But what if you wanted to? Here, for example, you might want to treat the fact that b is a 20, it's sort of a number. Can I actually make it into a number so I can do numeric addition? Or maybe you actually want to treat 10 as a string so you can just add them together or concatenate them together. Well, that's what type conversions are for. So if you take the type that you want to convert it into and pass your value to it, it converts it into a respective corresponding value, as long as it makes sense. So for example, if you pass string 20 into int, it actually returns integer 20. And now with this, you can actually do addition of those two numbers, just first converting 20 into an integer, and it happily does the computation. Right? You can also convert 30.4 into float just by so. Now, of course, if you try to do something like int of character a, it doesn't work because it makes no sense. Okay, so far so good.
Is it a 10?
No, so a is in character a.
Oh, character.
Yeah. Yeah, I should have been more careful. Or test. Integer of a test makes no sense whatsoever. All right. So, okay, this is actually one point that's good to cover is what happens with storage. So, let me just, throw the question at you, think about it, right? So here I'm basically defining new variable, or maybe we've already been using it, but I define a variable a equals 10. And now I'd set b equal to a. Okay? If I print them out, it should be both the same, obviously, right? The question is, now if I change b to 15, what will happen? What will be the message, right? Would it be 1515? 1015. Correct. So this is just to highlight the fact that just because you use to assign from one to another, it doesn't establish any sort of special linkage between them, right? It's just used to evaluate on the spot, and then once it's evaluated, that's it. It has nothing to do with each other. We'll revisit this point later. Okay, so now we're actually moving on. I actually do want to cover this before I give you a bit of break, is the structured data. So far we've been talking about what I will consider more or less simple data types, like integers, floats, strings. That one single value at a time. Of course, as you work on more complex questions, if you actually work on experiments, you actually want to deal with more complex data where you might have sequences of numbers, or you might actually have some sort of like collection of data which each of them are labeled, but they have to be treated together. This is precisely what structured data types are for. And in Python, there are multiple structured data types, but there are 3 essential ones, and we're going to start with 2 of those, lists and dictionaries. So a list, as it sounds like, is just a sequence of values. But before we get into lists, let me just try to motivate the problem a bit. So say you're trying to make some recording from your mice, maybe you're just doing some sort of spike rates or some behavioral response over multiple days, and you're trying to keep track of it. One way you could imagine is just say day 1 variable equals 10.5, day 2 equals 30.2, so on and so forth. You have as many variables as the number of days you record. Sure, you could do that, right? But the issue is you can imagine if you have hundreds of these, you're going to have 100 variables, and if you actually want to do anything with them, you have to deal with 100 variables, right? It really doesn't scale well, right? So this is what lists are for. Lists actually lets you have one variable as a container of multiple values put together. So here, you can actually create a list by using this bracket notation. So in the bracket, you put in the values you want, and you just assign the result into a variable. So here, I just created a list with 3 values in it, and we can look at the content just by looking at the responses variable. And if you look at the type of responses, it's a list. So this is a new data type. This is a structured data type. So it's a bit more complex than integer, floats, or strings because it actually contains multiple other values. So far, so good? You can, of course, make string lists out of strings. You don't have to be numbers, right? And you can print it out. Now, of course, being able to put values into strings, this list is nice, but if you cannot access individual elements, it's completely useless, right? So obviously, there's a way to access individual elements, and you again use the bracket notation to index into your list. So if you actually want to say access the first element of your responses, which should be up here 10.5, you index with 0. So that returns the first element. If you use 1, it indexes into the second element, which is 30.2, and then 2 for the third element, 50.8. Yes, in Python, indexing starts at 0. If you're used to maybe MATLAB, which indexing starts at 1, this might feel awkward. I'm not going to really go into this because there's a long debate, which is still not settled in any way whatsoever, about whether one makes more sense than another. Zero-based indexing has long traditional history, many reasons why this makes sense, but also many reasons might be slightly counterintuitive. One has some benefits and demerits as well. So I'm not really going to go into it. Since I'm a heavy Python user and C programmer and whatnot, I tend to like 0 better, but when it comes to necessities like using MATLAB and Fortran, I'll use index equals 1. So there's no reason to be too religious about this. Just learn what it is, the indexing scheme for the language you're using, and just work with it. In Python, it starts at 0. Now, one nice thing about indexing in Python lists is that you can actually go backwards. So if you're saying I'm interested in like the last element, if you use a negative number, it actually comes from backward. So -1 means the last element. -2 is second to last element. So this is a way by which you can go backward on your list to get to the element you're interested in. Okay, the question is, what happens if you index into something that doesn't exist? So we only had 3 elements, so there's index 0, 1, and 2. What happens if I try to access index 3, which is the 4th element, which doesn't exist? It's an error, okay? In some other languages, I'm going to keep on bringing this some other languages concept just for fun, but some other languages, they actually don't prevent you, and they just let you go haywire in the memory, and this has been like a famous problem with languages like C, where you can actually mess up memory just by accessing something you're not supposed to access. Python is a bit nicer than that. It tells you you're not supposed to do that. And one thing is if you want to know, so if you're limited by where you can access, you obviously want to know how many elements on the list. So that's what the len function is for. So if you take a len function and pass in your list, it tells you how many elements it has. Okay, so far so good? Make sense? Okay, if you're fixed with the list as you created it, it's actually not as useful. You actually want to be able to modify lists, put more elements in it. So that's what adding elements into a list is all about. In fact, let's actually even start with the completely empty list, right? And since everyone loves dogs, including myself, we're going to talk about like putting dogs in it. So I create an empty list called dogs, and I use the append method on the list to add new elements into the list. So here I'm appending 3 values: Doberman, Siberian Husky, and Pug. And after I do that, I just print out. And you notice that the list is now populated with 3 values. Of course, you don't have to start out with an empty list. You could have started out with something that has already initial content, like this, and then add more values in it. Okay, so append is your friend when it comes to adding more values into your list. Again, I'll skip this one since it's a bit obvious. I think it's far better for you to revisit the exercise on this one and try yourself. Make sure you can do it. Okay. All right. One thing I have intentionally not been doing it, but just to illustrate a point, is that you can actually mix types in a list. You don't have to stick with all numbers or all strings. A list can contain any mixture of data types you like. So if you find a usage for that, you're not restricted by any sort of like type, synchronicity type uniform rules. You can mix them all up, no issues. Okay, one key thing about lists, and we actually kind of already seen it by adding elements, is the fact it's mutable. And we'll get back to this very soon, but what this means is that after you created a list, you can change its content. Not necessarily in just adding stuff, you can actually delete stuff or change stuff in place. Okay, so what does it mean? So if I have a list called values, and I assign A, B, and C, so there are 3 elements, and I decide that, okay, the second element actually was supposed to be X, well, what I can do is I can just access the second element and assign X into it, and now value contains A, X, C. Right, so you can change it in place. And you can also remove things out of your list, and there are 2 popular ways of doing it. There's more than 2 ways of doing it, in fact, but 2 ways that you probably should know is using del command and pop method. So del is where you basically take the element you want to get rid of. So say I want to get rid of the one at index 1, so that corresponds to cat. Yeah, so we're going to delete cat out of the list by saying del animal 1. Okay, and after you execute, if you look at the animals, the index 1 element, the cat, is gone. So that's one way to do it. Another one is use the pop method. So pop is a method, which means that you actually call what animals.pop, and again you pass in the index to pop out of the list. The difference from del is that once it pops out of the list, it actually gives you back the value, so you can actually have a chance to store it somewhere. So here, for example, I popped the one at index 3, which should be what? So notice it's actually now, after modification, I'm actually doing it. So it would be mouse, right? So I'm popping the index 3, and now I get to look at what happened to the list and also what was removed. And you can see that now it's shorter, and I actually know the value that was removed because I stored it in a variable. Make sense? So here's an exercise just to give you an overview of what you're supposed to do with here. Here's an exercise where you're just supposed to go correct a bunch of issues with this. So here I want you to just get rid of anything that's not an animal name. And if it's an animal name, make sure it's spelled correctly. Okay. So that, yeah, we might as well actually try it. So I will work on it myself as well. So one thing you have to be careful is that as soon as you delete or pop an index, the rest of them shifts. So you cannot just use the index from the very first state, right? If you run into an issue, just rerun this thing to repopulate the list and then try again. So sometimes it becomes a bit tricky. And it might be helpful for you to know that when you're deleting or popping, you can also use negative indices. And just to see, type your variable name to see your final result. And it should look like that. Yep. Yeah. Yeah, so this is the one in which you have to keep on practicing to get used to it. All right, so moving on is slicing. So once in a while when you have a list, you actually want to have a subset of the list. Say a consecutive subset to make things easier. Well, there's actually, one way to do it is like you just pop the element and put it into a new list. You could totally do that. But if it's as long as it's consecutive, there's actually, or consecutive or some pattern to it, there's this slicing that you can perform to create a new list out of an existing list. So say I actually want the first 3 elements of the list, I can use this slicing notation where it's 0, 3. And oops, actually I have to define this first. I have to run this guy. And if I run this, now it returns a list of the first 3 elements. Right? So syntax is start, stop, skip, or step. Where here in this case I ignore skip. We'll get back to it. So start thinking with the start, stop. Start, as you can imagine, is the index of the first element you want to take out. What's tricky is a stop. Here I said stop equals 3, but if you really think about it, index 3 is D, right? By my list, it's not returned. This is because the stop is what indicates a stopping point, but in itself is not going to be included. So that could be tricky. There are good reasons behind this, but it will probably get you the first couple of times, so just practice and get used to this. Make sense? And in fact, you can actually skip, as in you can actually like ignore some of these values and let it be the default. If you don't specify the first number, it's by default going to be 0. If you don't specify the second number, by default it's going to be the very last element. In fact, what it's going to be, it's going to be the length of the list. All right. So for example, if I actually, let me actually just demonstrate it. So if I actually characters, and this goes from the beginning up to but not including index 5. Or actually more easy to read, this means first 5 characters, or first 5 elements if you put it this way. Okay? If I do this, it means starting at the index 3, so 4th index and beyond, this is what you get. And you can also use negative indices as a start. So you can actually say last 3 elements of a list. You can just say -3 to the end of the list. You get that. Okay, so as I said, if you ignore the first one, it just gives you from the very first to the element you specify, not including the index you specify for the end. Now, interesting one is the steps or skip. I use that term interchangeably. This is by which how many you proceed from one element to another. So it's probably just easiest for me to show. So if I say 0, 6, 2, it means starting at 0, going up to index 6, but not including 6, at the step of 2, it skips every other character. If I make index skip to 3, it skips 2 characters in between. Kind of like that. Okay? So this is just a way for you to proceed through the elements and get, say, every other element or every nth element, every step element. In fact, if you actually just want to go from very beginning to the end, skipping every other character, you can ignore the first 2 values, start and stop, and just say the last one. So this is saying, give me every other element, including starting from the very beginning. Now, one nice and cool trick is what happens if you actually give a step of negative. Any guess? What will happen if I did this? Yes, it flips, right? Because you're stepping now negatively. So if you put negative, it understands that what you're trying to do is going from back to front. So it just reverses the list. So this is a very common trick to reverse a list. All right. So just like we were able to add numbers and subtract and multiply numbers and add and multiply things onto strings, you can also do some arithmetic operations on lists. The first one is addition. So just intuitively, most things are intuitive. Intuitively speaking, if I give you 2 lists and I said I want to add them together, what would you expect? one list, right? Concatenated list. And that's exactly what you get. You get a concatenated list back. Okay? This is also called list extension. Now, next one was like, what happens if I multiply a list? You kind of seen a case of it when I multiply a string, so maybe you can already guess. It repeats the element. So here it was hello and world. It's a 2-element list. If I multiply 5 times, it multiplies that list 5 times. So you can almost think of it preparing that n times and concatenating all. So that's why it's hello, world, not like hello, 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 world, 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 world. Okay? So that's it for lists. Any questions so far? So far, so good? I mean, yeah, we'll get to that. Multidimensional lists, I'll get a bit to it. It's coming up. All right, but before we get into multidimensional lists or more like composite of composite types, we want to talk about another important one, which is called dictionaries. So, okay, so a scenario will be something like this. Now what you want to do is store information, say, about your experiment. So there are many things you have to keep track of, things you probably jot down in your lab notebook, right? Maybe you have to jot down the date of your experiment, the mouse ID for the mouse you're working on, the protocol that you're working under, the particular stimulus that you're actually currently using or you will be using for your upcoming experiment. So there are these different values you want to keep track of, but each of them are associated with some meanings to it, right? Now, one way you could imagine just organizing this and keeping in one place would be, say, just put in a list, right? I have mouse ID, I have an experiment date, and I have stimulus protocol. Why don't I just put them all in a list and call it setups? Okay, I mean, at least you put it in one place. At least they're all kind of, put together. The issue is that this is really hard to work with, right? And it's also very counterintuitive, or actually simply not intuitive. Like, if I actually want to access the date, you have to somehow know it's the index 1, meaning there's a second element into the list. You could look at the list and maybe you can guess, but sometimes values itself is not that enlightening about exactly what the value represents, right? So putting these things where you have a bunch of values and each of them have a meaning just into a list tends to create confusion down the line because you have to somehow keep track of what each index means separately. It's not really in the data structure itself. Right? So you're kind of using position as a surrogate for a meaning. And this mapping of position to what this is, the label for the data, has to happen somewhere else outside of your code. And if you do anything that depends heavily on something outside the code, that's going to create an issue down the line. People other than you might not be able to understand it, and you yourself, 3 months down the line, you're not going to understand it. That's actually one good rule of thumb. If someone else cannot understand it right now, you in 3 months wouldn't understand your code. Okay? So just be aware. By making it easy for others to understand, you're not actually being helpful to others. You're being helpful to yourself in 3 months. Okay, so I mean, with enough of that, obviously this is not the way to do it. What you want is a dictionary. Dictionary is also typically known as key value pair, mapping. It's basically a way of associating values with some label. At least you can start with that idea first. So here you create a dictionary by opening curly braces, and in there you specify key and value separated by colon, and multiple of those entries separated by comma. So kind of like this. So I'm basically saying mouse ID is a string, is a label, or key, and my value is the mouse ID 1, 2, 3, 4. Date is a label or key, and 2018 July 1st is the value. Protocol is the label, and orientation classification is the value. I define it. It happily creates that variable as a dictionary, and I can look at it, and it contains those values. Okay, so here was just an exercise creating it. It's identical to what we just did, so I'll skip it. Again, try to do it on your own. Now, again, if you create a data structure that you cannot access, it's quite useless. You obviously want to be able to access into it. So the way you do it is actually pretty similar to lists. You actually just use the bracket to index into it, but rather than using a position, you actually now use the key. The value of the key itself to be able to access the value that corresponds to it. So let's say we actually want to get the mouse ID. Well, you just say setups, mouse ID in quotes, because it was a string that was a key, and you get the mouse ID back. Notice now it's so much easier to understand what this is extracting out of the setups data structure. Right? It's quite obvious from the label. Now, if you try to access something that doesn't exist in your dictionary, well, it throws an error, right? It's a key error. The key is not found in your dictionary. Okay, so just like lists where you could add more elements after the fact, you could also add more elements after the fact into a dictionary. And in fact, all you have to do is just assign into a key that doesn't exist. So assignment-wise, this works just fine. If you try to access it when a key doesn't exist, it would throw an error because you're asking, like, give me a value for that key, which doesn't exist. But if you're just assigning it, you're assigning a new value into that key, and there's no problem with that. So here I'm assigning an experimenter as myself. And now if I look at the dictionary, it contains that new information of experimenter in it. Now, one thing to keep in mind about dictionary is the order. Is the fact that order of the keys are not necessarily going to be the order in which you add them. Because the fundamental idea is that in dictionary, the key order is not important. So Python would not actually try to keep it for you. It would actually completely ignore the order by which you create the keys. So don't ever write a code that depends on the order of the keys in the dictionary. Okay, so here I'm just creating another one. So basically I start out now with the empty dictionary. You can create an empty dictionary just by open close braces without putting anything in between. And I'm just assigning new key values, mouse 1, mouse 2, mouse X, and finally take a look at it. So far it should be pretty straightforward. Okay, so modification happens just like the list, right? In the list, you index to the value, and then you just change the value in spot. Same thing with dictionary. You just get to the value and overwrite. Get to the particular key and just override the value. So in the earlier setups, maybe I actually want to update it with the January 1st. I just do that, and that happily overwrites the value. Okay, and deletion happens the very same way. You actually can use del keyword or pop, very much like the way you use for list. So you can say del, and now that just got rid of entry from Tokyo and the temperatures. We'll look at it. It got rid of it. Or you can pop. If you pop a particular key, it returns the value that was corresponding to the key, so you can keep it. Okay, so in this case, if I pop Trondheim, it returns the value 50, and that goes into removed, and you can verify that fact. Okay. Okay, so I'm not going to go through this. I want you to complete on your own. So here basically I'm saying is that take the data dictionary here and make modifications, maybe add new elements, change the one that already exists, or delete elements to make it ultimately look like this. And by your name here, I mean like you put your name on there, just to personalize it. Now beware, again, the order of your dictionary may not come out like this when you print it out. That's okay, right? Order doesn't matter. Just worry about the content, yeah? There's no key indexing in dictionary. That is correct. Order of the keys are not respected. There's a particular data structure called order dict that actually also respects the ordering of the dictionary keys. So if that ever comes as a real necessity, you can use that. But majority of the cases when you use dictionaries, order doesn't matter. All right, so okay, at this point, I actually want to quickly talk about immutable versus mutable data types. So before I do that, I'm just going to quickly revisit what you already seen earlier. So here I have two variables assigning two integers, 10 and 20. All right. So of course, when I do that, they are just completely separate. They're completely different values, obvious. If I now assign x equals 30, wait, actually I'm missing something. I might not. Now, if I change x equals 30, y had nothing to do with it, so obviously it doesn't change y. We've already seen that even if I actually, in fact, assign x into y and now change x, it doesn't affect y, right? Now, what happens if I do this for dictionaries or lists? So I create a new list called fruits, has a couple contents in it, and I create a new list called my_fruits and assign fruits into it. So obviously, if I look at the my fruits content, it looks just like fruits. So far, so good. Now I take the fruits and append a new element into it. I add a new item into the fruits list, right? So fruits now has kiwi in it, okay? No problem, right? What happens to my fruits? What's your guess? Would it contain kiwi or not? It does. Okay, so this actually then brings me to the only presentation of the day on variables in Python. Okay, so this is going to be as CS heavy or computer science heavy as it gets in this course, so you get a bit of taste of how deep in CS topic I tend to get into. I tend to not really get too much into CS thing. I'm not really going to talk about algorithmic efficiency, proof of algorithm correctness, and all those things. If you're interested, come talk to me. I'll be more than happy to talk about it. But this is somewhat useful. Knowing how variables somewhat works in Python can actually help you debug your code. So when you think about variables, say the code is x equals 10, in your mind, maybe what you're thinking is that, okay, somewhere in computer memory, it creates a box called x and assigns value 10 into it. Yeah? Does it sound like what you're thinking what variable would be? Okay, maybe, right? Turns out that's not right. Okay, in Python, this is not how it works. In Python, when you say x equals 10, the first thing that happens is that it creates an object or this location in memory that contains the value 10 first, and then creates a variable x, which refers to this object. Okay? Now, if I create another variable with y equals 20, again, it creates 20 first, and then variable y refers to 20. So far, so good? Now, if I say x equals 15, what do you think happens? Yeah, so I mean, one, you might have thought, like, maybe does it change it over here to 15? Actually, it doesn't, right? It actually creates 15 and swaps the reference to 15, which leaves 10 hanging around. It actually will hang around in the memory until after a while Python decides that, okay, the one's using it, I'm going to get rid of it in the process called garbage collection. Okay? Now what happens, okay, maybe because we changed the value altogether, that's why it caused it to just switch to a new value. What if I take x, add a new value, add something to it, and reassign? So shouldn't that be in-place modification? Maybe you're thinking this will now finally change to 18. No, it turns out it takes x as a 15, add 3 to it, it results as 18, creates a value 18, and swap x to refer to it. Okay, and then again, 15 will disappear eventually. Now, so now with this in mind, if I have x equals 10, and now I say y equals x, y simply refers to the same 10 in the memory. But if I now say x equals 20, what happens? Creates 20 and make x point to that. Okay? So this is the reason in which like changing x doesn't affect y, because in reality you're not changing x per se, you just x refers to someone else. So this brings to the point that in Python variables are nothing but references to objects or some location in memory or some content in memory, and they themselves are not the containers. Okay? So these are the objects in memory. These are references. Got it? So simple object types, for example, like integer, floats, and strings are immutable, meaning that there's really no way you can change it. Notice that in all the operations we perform, there's nothing I could change 20 into 23. If something results in 23, new 23 gets created, 20 never got changed. These are immutable data types. Okay, well, so that being said, let's now look at dictionaries or lists. Here we're going to talk about dictionary. When I say x equals a new dictionary with the value, key value of year 2018, the first thing it does, it creates the dictionary object into memory, creates x, makes it refer to the memory or object in the memory. Okay? Now, if I say x year is 2020, I'm basically doing modification. What that actually changes the content of the memory, right? So complex objects, or I say complex, for example, lists and dictionaries are mutable. The object content itself can change. So the result, what that means is the implication is that if I have x and y both pointing to the same dictionary, And if I use any one of them, here say I use Y to refer to the dictionary and add a new key value pair, it will just change the object. And because X and Y are just referring to objects, now if you look at true X, obviously that object will have topic brain. Okay? So it's just an alias. Right? X and Y themselves are really not containing anything. They just refer to an object. And because dictionaries and lists are immutable, they can change themselves. If you change it through one alias, obviously if you access it through another alias, well, you're talking about the same object. It is changed. Okay, so that's all I have for that portion of it. Make sense? So far so good? Okay, so that's what I meant just with the mutable versus immutable objects. Now, for lists, it turns out there's an immutable kind of list called tuples. That's all it is. Basically, if you create using a tuple notation, so notice that instead of using square brackets, I just use parentheses to create this list-looking thing. It looks and behaves just like list. You can index into it, you can slice it, but you cannot change anything about it. If I try to modify the content, it errors out. If I try to delete its element, it errors out. So if you ever come to a need where you want a list fixed, tuple is your option. We'll get more to why this might be useful when we talk about functions in the next session. All right, so with that, I kind of expected it would be a bit slower today. There's one more section about control flows, so I'll just give you guys like a minute of a break to stretch out. And if you have any question, this is a good time to ask before I move on to control flows, which makes your code a bit more complex but more exciting. All right. Okay, so now let's, we covered a lot already. We already covered data types, values, variables, even actually went into how Python variable works. But so far, everything we write has been having this one structure of going from top to bottom one line at a time, right? And that kind of gets boring pretty quickly. Like there's really no like twists and turns and loops going around your code, and this is what exactly control flow is all about. So key about control flow is that you actually want to make your code make some decisions about the world. If your code is only there to follow your instructions to the T every line at a time, that's not that interesting. You want them to act a bit more smartly, making some decisions according to something that's happening either inside the code or maybe on the computer or even outside the world, depending on how you provide the information to it. Also, we still haven't really figured out how to save ourselves some time if some things are repeated many times, right? Maybe we actually want to do the same operation to every element of a list and we yet to encounter how to do that. So that's what the loops are going to be for. But before we dive into that very exciting topic of control flow, I do want to talk about how to make your code a bit more interactive. Because so far, everything's been happening based on what you already typed. Right? Your code doesn't really ask anything. It doesn't really work with external world information. So that's what this interactivity is about. You can actually make your code prompt you for something by using this function called input. So here, if you type input, and here's a message along with it, let's just see what happens. So if you run this, it should give you this prompt box, right? And it tells you like it's kind of being nice, asking for your name. So if you're going to be nice to them and tell your name, it will actually give you a personalized message back. So this is a beginning of you making code that is a bit more interactive, something that can actually interact with the end user. 99% of the time, end user is yourself. Yeah? But this could be very helpful, for example, maybe as a way for you to input information at the very beginning of your session. Maybe you can write a code that it just prompts you for critical information about your experiment, and if you put them in, they'll put that into a dictionary, maybe put some of those into lists, and maybe even save it to a file. So you can already see this is the beginning of interactive usage of your Python code. Yes?
Why is the second line always not?
Second.
Hello, what's your name?
Hello, what's your name, Edgar? Oh, yeah, sometimes it actually messes with the ordering. It also has to do with, I bet if I actually shrink down my notebook, then it actually would look differently. I don't know how it comes up. The interactivity on the Python notebook itself sometimes has a bit of quirks, especially in this setup of me providing a Jupyter Hub tends to have a bit more quirks when it comes to inputs. So once we actually move on to your laptop-based setup, things should be a bit smoother. but it should still work here.
It shouldn't be
Hmm?
So it shouldn't be printed out.
It should, well, so it would be printed, was here, the input portion is printed out. So like basically this message is going to be what it prints to prompt you for a message, and it will just remain there after you put your response. So that's what the message it printed, that was my response. And then I have a statement that uses what's returned to print out a personalized message. It's just like what's weird here is the order is flipped. Okay, so let's do the next one. Here, basically, is asking like write a script that asks for a number, and then it returns the number squared. So try it first. I'll actually give you like a minute to try, and then I will show you how to deal with it. All right, so I'm just going to start it myself. So I'm going to assume I want an input. I'll give a nice message saying like, enter a number. And then I'm just going to say, I'm going to be plain and just going to return squared. Have you guys already run and try? Did anyone run into error? People doesn't run into error with this, I'll be like super impressed. So, okay, fine. Here, if I'm actually like putting something like this, where I've just blindly thought like, oh, I'm just asking for a number, I'm just going to square it. Well, let's try it. I ask for a number. It errors out, right? And if you read it, so again, it's good to try to read the error. As cryptic as it might sound, it actually is telling you all the right information. It's saying type error, unsupported operand types, square square, which is the same thing as pog, on string, and well, quotes int. Well, basically, the first portion is the right portion. What it's basically saying is that you cannot square a string. And it's a string because that's what input always returns. Even if you put a character that will otherwise look like a number, it returns a string. So, but we already learned earlier how to deal with that. You just type convert, right? So I could either say something like x equals int of an x, so reassign x. Or if I tend to actually like to put everything in one line, so I could say int around the input to begin with. Okay. Now I try again, and now it works. Okay. Okay. So now you've learned how to talk a bit better with your computer. This is time to actually learn about conditional executions and control flows. Yes.
Is there a reason you chose to just print the square of a number rather than reassign the square of a number to
A variable?
the
Oh, no, not really, no. It's just like, I wouldn't reassign unless I had intention to use it. And in this case, since I was just like doing one-shot print, I felt like I just do square and print it. You could totally reassign it to x, assign it to another variable. Yeah. Okay, so what I want to do now is I want to be able to do a bit more smart decisions based on the input. We already know how to now get input from the user. Here I'm actually like not putting a user, but x could very well be an input from the user, so replace it with int input enter a number statement. And what I want to do is like print out a message if the number is divisible by 3, because that's what we always care about, right? Whether a number is divisible by 3. Yeah, I know. Yeah. Do you guys? Okay. There's obviously a trick to figure out if a number is divisible by 3. There's a trick to figure out if a number is divisible by 7. There's a trick to figure out if it's divisible by 11. If you're curious, I can tell you, but that's not the main point here. Say you care if a number is divisible by 3, and only if it's divisible by 3, you want to print out a message. So currently, if I just run this code, it prints out complete nonsense. 19 is not divisible by 3. We want this print to only occur if the number is divisible by 3. If the number is divisible by 3. Obviously, I'm talking about if condition expression. I want something to execute only when a condition is met. So you write this in Python by saying if some expression followed by colon, and then tab indent, and whatever that goes in the tab section is what gets executed only if the condition meets. Okay, so what are you talking about when we say expression or condition? Well, this expression has to evaluate into a new type of value we're going to encounter now called Boolean. value, which is essentially true or false. Okay, so in fact you can just write it as this. I can say if true, print, this will be printed. Well, it's true, so it will be printed. Or if false, this will never be printed. Well, false is not true, so this wouldn't be printed. I mean, you can run it for the sake of it. The one that's under true will be printed. The one that's under false wouldn't be printed. Obviously, this is pretty boring. This itself is utterly useless. What you want is this true or false to come out of expression evaluation. You want to compute this value. So you get to it. I'm just saying basically type true is bool or Boolean type. What you want to do is you want to come up with an expression that evaluates the true or false. And there are many expressions that leads to this. So for example, there's a double equal, which is an equality check expression. So if the two numbers are equal, this will evaluate to true. If it's not equal, it values to false. As you can see here, 5 is equal to 5, so it prints true. 5 is not equal to 6, so 5 is not equal to 8, so if you say, is 5 equal to 8, answer is false. If you want to ask if it is not equal to each other, you can do this exclamation equal to. So here's asking, is 5 not equal to 7? Correct, it's not equal to 7, so this will print true. And there's inequality checks. You can say, is 12 greater than or equal to 10? True. Is 3 less than negative 3? False. So that should be true and false. So you're getting a hang of it. So obviously I'm not saying you will actually find this exact line of code in your this exact line of expression. If I ever read a code that says if 12 is greater than or equal to 10, that's a mistake for sure. It makes absolutely no sense you're doing that. What you want is one of those values to be something that you might be a bit unsure about. Maybe it's something the user is going to put in. So you want to check, right? So one example is I'm going to have a variable x. Here, of course, I know it's 0, but you can even pretend like maybe this came from somewhere. You're not sure about the value, and you want to print the statement x equals 0 only if, well, x equals 0. The way you write is that if x equals 0. So this evaluates the true only if x is actually equal to 0. It will print this statement. Now x is equal to 0, so if I run it, it will print that statement. Right? Now if I change this to anything but 0, it will not print that statement. Of course, it would be more interesting if I actually change this quickly. It would say something that inputs and say enter a number. And now I can actually have a code that interacts with me a bit more. If I put 0, it will print. If I try again, and if I put something that's not 0, it wouldn't print a message. So now you're already having a code that acts differently according to an input. Okay, so now in order for us to actually solve this divisible by 3 issue, we have to know one more thing, which is this check of how to check for divisibility. Right? Now, one approach towards it, there are actually a couple approaches, but one approach is to see if when you divide it by something, if there's a remainder. Right? If there's no remainder, then that's by definition divisible. And it still turns out that Python has an operator to give you the remainder of a division, and that's called a modulus, which is written as percent. So if you say 18 modulus 7, what it returns is that 18 divided by 7, the remainder of that. So if you divide 18 by 7, what's the remainder? Well, 7 goes in it twice. 4. So you should get 4. If you divide 30 by 5, what's the remainder? 0. It's completely divisible, right? So that gives you 0. So with this, we can actually finally write our code. We can actually say, well, so x could be again anything, x could be an input as well. But now we actually want to write an if statement that actually checks if it's divisible by 3. So why don't you take a minute or two trying to write this, and then I'll follow up and write it up. I think we'll try to cover up to else. And yeah, I think I'll leave it like that for today. Where did I go? that doesn't work? Oh, if you ever run into that, sometimes you just have to refresh the browser. Yeah, that shouldn't get rid of the progress you made. So, yeah, I think that's a bug with the Jupyter Lab. Jupyter Lab technically is still an alpha release, so that's why once in a while it still has a bit of quirk. Yeah. Okay. All right. So let me actually start with my thing, right? So I'm gonna give you a bit of like what the outline or what this sort of looks like. So again, it should be if, and I'm gonna write something that evaluates true only if it's divisible by 3. And then we'll have a colon and a tab, and the rest should be fine. So it's just a matter of coming out with the expression here. Well, I want to check if it's divisible by 3, which is the same thing as saying if I were to divide it by 3, is the remainder equal to 0, right? So let's just do that. X, so to get the remainder of division by 3 is x modulus 3. And now I want to see if this equal to 0. Yeah? And 21 is divisible by 3, so it prints out the statement. Just to check for yourself, what if I print 19? This should not print anything. It indeed doesn't print anything. So that seems to be working. Okay? Good? Make sense? Okay. Now, what if I actually wanted to give another statement if the condition doesn't meet? Sometimes you actually want to do more like one branch versus another branch kind of approach, right? So if a condition meets, you want to say something or do something, one. But if the condition doesn't meet, then you want to do something else. So here, for example, like maybe I want to say like if it's very big, I want to print out like or bigger than 1,000, I want to say that hey, that's a pretty big number. If it's less than 1,000, I want to say that's an okay or normal number. So notice that now it's a complete branching. So earlier with just if, it was more like if the special case meets, then you have the special thing that happens and then proceed with the rest of the code. Here now you're really branching it off to one condition versus another. So this is why typically in if else, these are called branching in your code. So here you do by else. If you say if a condition, and you have its own statement here, and then another one that starts with else, this gets executed only if this condition is not true. So you can try this. If I run this, and if I say 3,000, so that should be true for x greater than 1,000, the first block runs. So it should print that's a pretty big number. Now if I try again and put something that's pretty small, like maybe 3, now it doesn't meet the condition of number greater than 1,000, so it should print that's a reasonable number. Now based on this, the question would be, what happens if I put 1,000? Would it tell me it's a pretty big number or is it a reasonable number? Reasonable number, right? Because it's not greater than 1,000, right? So that should say it's a reasonable number. If I had it greater than or equal to 1,000, and if I put 1,000, it would say it's a pretty big number. So these edge cases of your condition, you should always check, right? Because those are special cases where one branch goes away from another branch, and that's usually where a bug occurs. Okay, and I guess this will be the last thing today. Finally, what if you not just want to do 1 out of 2 decision, but 1 out of 3, 1 out of 4, maybe just like n decisions or n branching. You want to check for n conditions and do one of them. Well, you can do that. So say, for example, maybe what I want to do is print out a statement whether your number is negative, 0, or positive, right? I could do that. First, for example, maybe I could approach by saying check whether it's negative first, right? And if it's not, that means it's either 0 or positive. Then do another check. This time I ask, is it 0? And if it's still not, then I know it's positive. So this is one way to do it, right? So let's try. If I say 3, it goes into good positive. Okay, that's fine, but you can imagine if you actually say 4 conditions or 5 conditions, this indentation has to continue on. Your code gets more and more left shifted, it becomes harder to read, and it becomes harder, it's just in general ugly code. Fortunately, Python actually gives you a special way to combine else with if. So if you have if lying inside else, you can just merge them together to call it elif. So you can rewrite this whole code in this format. So say if number is less than 0, do this. elif number is equal to 0. So this is again, this rest only gets executed if this is not true. So this is identical to this really, but it keeps it flat structure this way. So if elif, else. So it becomes equivalent branches. Only one of these three things will ever get executed. So it should work just the same way. And here I'm just demonstrating you can actually have arbitrarily many elifs. Right? So here actually I'm just checking, is your number 0, 1, 2, 3, and else, which is catch-all case at the very end. It's like, okay, your number is not any one of the ones I tried. Okay? If you happen to know other language, this is exactly identical to switch case statements. Okay? It doesn't mean anything to you. Don't worry about it. Just think the fact that you don't have to know switch case, because this is far easier to work with. Okay, well, so actually we should start cleaning. I guess one last statement I'm going to make. So we didn't quite cover the for loop. I think that's fine. We'll cover that at the beginning of the next session. Next session we're going to cover basically for loops, functions, and a bit about how to organize your code into files. And look a bit about this concept of object-oriented programming, but not too much. That's really going to be the next. So as I said, I actually left a lot of leeway into the next session in case, just to see where things goes. So between today and tomorrow, so since this is the first session, I think it's actually totally fine. I'm not giving you homework assignments per se. Besides, even if I was to get to the end of the notebook, the homework assignment was going to be like, try it, see if you can figure out. I'm not going to really grade it this time, because this is not the one in which I have a great submission system set up for. But I want you guys to just try to revisit this notebook and try all the exercises that we haven't visited. Just try on your own, and maybe just try new cases, come up with a new problem, see if you can solve it. And if you feel like it, go ahead, read on the rest of the notebook, see if the for loop already makes sense. The looping makes sense or not, right? It's totally fine to just go ahead and do it. I will add the next notebook that contains content for the next session. I'm probably going to move things around so the for loop content makes into the second notebook, so it's obvious which session covered what. But this notebook will be left untouched. Okay, the only last thing was basically this Boolean operation. So if you want to do a bit more complex checks of multiple things, for example, you want to make sure that x is greater than 10 and y is greater than 100. Well, that's what n is for. So you tend to have these truth table where you have x and y and what it evaluates to. You can just look at it. It should be more or less intuitive. Same thing goes with OR. So I basically have all the examples associated with, and there's a bit about membership. So I do recommend that you just simply go through it. Read definitely up until the for loops. I will start at the for loops next time, and I will take any questions regarding anything we didn't cover between this and the for loop. And if you feel like it, also you can read through the for loops, but I don't expect you to complete it. Okay? But definitely try to complete the exercises we skipped over. All right, I think that's enough for the first day.